So, we want to test for alkanes in paper 3. I said, paper 3, under qualitative analysis, we have test for cations and anions. Then we have part that deals with test for organic compounds. So the organic compounds tested in paper 3, we have alkanes, alkenes, alkynes, alkanols, alkanoic acids. Alkanes, alkenes, alkynes, alkanols, alkanoic acids. So we want to begin with the alkanes. But before we begin with alkanes, what you should know is that sometimes when you're giving a solid, you may not know whether you are dealing with organic compound or inorganic compound. Inorganic compounds are the metals or non-metal ions, cations or anions. But the main thing, apart from the chemicals provided, burning that solid alone can make you know whether you are dealing with organic compounds or inorganic compounds. For example, when you burn organic compound, the organic compound first melt, then burn. While inorganic compounds like metal, iron, metal, when they burn without melting. And if there is no burning, then we can still use some chemicals provided. There are specific chemicals that are only used on organic compounds but not inorganic compounds. For example, we have acidified potassium dichromate 6, this one. We also have bromine water, though there are some inorganic compounds that we can use bromine water. For example, sulfites. Sulfite is a bleaching agent. It can bleach the brown bromine to colorless. But in most cases, when you see bromine water, acidified potassium manganate 7, and acidified potassium dichromate 6, you can just guess that this is organic compound and the type of question that come. So let's begin with the alkanes. So generally, alkanes have a general formula CnH2n plus 2. And I said this formula can help us come up with all molecular formulae. So this formula of an alkane generally can give us all the molecular formula of all alkanes in this group. So they have a general structural formula. This one, C dash dash dash. These are bonds. So that one means that alkanes, they have single bond, at least between carbon atoms. So when we want to represent structural formula for an alkane, we represent it by this structure. So alkanes have no effects on brown bromine water, acidified potassium manganate 7, that is purple, acidified potassium dichromate 6, that is orange. But some melt and burn with blue flame, and that is about alkanes. So I want to again give you a brief description of alkenes. So alkanes, before we go to alkenes, they have double single bond. They generally have single bond between carbon atoms. Between carbon atoms. Let's move to alkenes. So let me rub in. Alkenes. So alkenes have double bond, at least a double bond between carbon atoms. So have double bonds. Alkenes have double bonds. They have a general formula. Have a general formula. They have a general formula CnH2n. Have a general structural formula. Have a general structural formula. C, then double bond in between the two carbon atoms. Then we put those bonds like that. So this is the general structure of alkenes. The general structure of alkenes. So alkenes are referred to as unsaturated hydrocarbons. They have unsaturated. So unsaturated hydrocarbons, they always melt and burn with yellow sooty flame. Why are we calling them unsaturated? We consider a ratio between carbon and hydrogen in its structure. So that makes it unsaturated. There are, when you compare that ratio is slim. So there is incomplete combustion of carbon due to small number of hydrogen. So the carbon become black. They are partially burned, so they become black and produce soot. Some also become white yellow and produce light. So next one, we have the effect on the three chemicals. So we have again, what is their effect on brown bromine water, purple acidified potassium manganate 7, orange acidified potassium dichromate 6. What is the effect? So they decolorize. They decolorize purple. They decolorize the following: purple acidified potassium manganate 7 and brown bromine water. And brown bromine water. So they decolorize these two. Alkenes decolorize purple acidified potassium manganate 7, and also they decolorize brown bromine water or orange bromine water. So it depends on the concentration of bromine. Alkenes turn orange acidified potassium dichromate 6 to green. The color of acidified potassium dichromate 6 turns green when we add few drops of a compound that we suspect to be alkene. So the only way we can know that the compound is alkene or alkyne when we add few drops of that solution, and the color changes from orange to green. Then we can say that this structure is present. So this general structure is going to help us write inferences. So another one, they melt and burn with yellow sooty flame. So they melt and burn with yellow sooty flame. They melt and burn with yellow sooty flame. They melt and burn with yellow sooty flame. That's why they are called unsaturated hydrocarbons. And then next one, we have alkynes. Alkynes, so I will just change something here. This general structural formula, this one, and this molecular formula, general formula for writing all molecules of alkynes. So alkynes have triple bonds, have triple bonds. They have triple bonds. That's why they are written as C, 1, 2, 3, then like that. So they have triple bonds. They have a general formula C2H2 minus 2. No, H2N minus 2. C2H2N minus 2. C2H2N minus 2. So they have a general structure C, 1, 2, 3, triple bond, then that one. So these are triple bonds. So alkynes have 3 bonds, at least between between 2 carbon atoms, at least. While alkenes, they have double bond between at least 2 carbon atoms. Then alkanes, they have single bond. Now, in terms of properties, chemical properties, physical properties, alkenes and alkynes share the same properties. So both alkenes and alkynes decolorize purple acidified potassium manganate 7. They decolorize brown bromine water, and they also have effect on orange acidified potassium dichromate 6. So they turn orange acidified potassium dichromate 6 to green. Both alkenes and alkynes, they have the same effect on orange acidified potassium dichromate 6. Again, in terms of burning and burning, I mean, they all melt and burn with yellow sooty flame. Yellow sooty flame. So this yellow sooty flame we can also call yellow smoky flame. And the smoke is produced when it is burning, and the color of the flame is yellow. So we can also call it yellow luminous flame. But alkanes, generally, some can burn with blue flame. That is called non-luminous flame. Then next one, we have alkanols. Alkanols. So alkanols. So these are also another group of organic compounds. These alkanols, they have a functional unit, OH. The functional unit is the active part of the compound. They are the ones that take part generally. In most cases, they take part in a chemical reaction. When they react as acid, they donate the hydrogen in front. But when they react as bases, they donate the whole OH, which is the functional unit. So alkanols have a general formula. This is the general formula, R dash OH. So you see this ROH, R means alkyl group. So alkyl, we learned that alkenes are alkanes minus one hydrogen. So when an alkane, from an alkane we subtract one hydrogen from an alkane, it forms alkyl group. So in the structures,